Hello dear students and welcome to Diksha Vedantu Foundation channel. In this channel we are currently discussing class 10th midterm score boosters, and in the science class today I am here with the chapter Human Eye and a Wonderful World. In a one short video here we are going to discuss entire topic of this chapter in form of questions. So most important questions from this chapter I will be discussing in this video. So if you want to boost your midterm score, don't forget to watch this video till the end. And let's start with the topic of today. First of all is human eye. Now human eye, the structure of eye is there, but most important thing in physics perspective is eye defects. Okay, there are three types of eye defects: myopia, hypermetropia and presbyopia. Then there is scattering of light. In scattering of light, what do we observe? Redness of the sun during the sunrise and sunset, blueness of the sky. Then red light scatters the less, that is also because of the scattering of light. Now atmospheric refraction is also there. In atmospheric refraction we see twinkling of stars, and planets do not twinkle. So in the night sky, if you see something is twinkling, that means that is definitely a star. But something which is appearing to be a star but not twinkling, actually that is a planet. Now advanced sunrise and delayed sunsets are also because of atmospheric refraction. Now another part is dispersion of light. Okay, dispersion of light is splitting of light into its constituent colors. Rainbows are formed due to natural dispersion of light. So we will discuss everything in today's lecture, today's video. So don't forget to watch this video in completely. Also, if you want the lecture notes, the class notes, the entire thing will be provided to you. Only one thing that you have to do, you have to click in the link given in the description. If you click on the link in the given description, then you can download the PDF from the website. Now let's start with the topic human eye. So first question: a student sitting on the last bench can read the letters written on the blackboard, but it is not able to read the letters written in his textbook. Which of the following statement is correct? Okay, so first of all, he can read the far objects that is written in the blackboard, but he cannot read whatever letters written in his textbook. Okay, so this is important. So he is not able to read his textbook. That means his near point has shifted far so that he can see the farthest objects, but he cannot see close objects. Also in the comment below mention what type of eye defect he has. Now in this case, near point of his eyes has receded away. Okay, so it moved away. Okay, the other points are, let's see, this is the correct option. Obviously the near point of his eyes has come closer to him. If the near point has come closer to him, then he would have be able to read the book easily. So that is not correct. The far point has no relation because he is not able to read objects which is closer to his eye. The far point of his eyes, also far point has nothing to do with this. Right, now let's move on to the next question. This is a short answer type question from your previous year question paper. A study of the diagram given below and answer the questions that follow. Name the defect of the vision depicted in this diagram, stating the part of the eye responsible for this condition. So as you can see that it's near point. If it was original near point, and if you keep an object here, the image is formed behind the retina. This is retina, as we know. So it is forming behind the retina. That means its near point has shifted behind. So this is called hypermetropia. So the first MCQ, the question that I asked, what type of eye defect it was, that was actually hypermetropia, right? So hypermetropia when happens is we cannot read any books, anything that is close to us. We can see the distant object clearly, but we cannot see any objects which is close to our eye, and the eye lens is responsible for that. Also the shape of the eye, many other things are responsible, but main culprit is eye lens because it cannot focus the closest object into the retina. So main thing that is responsible for this is eye lens. Okay, now let's move on to the next part. Study the diagram given below and answer the questions that follow. List 2 causes of this defect. So what are the possible 2 causes? So the focal length of the eye lens is too long. Obviously the focal length of the eye lens is too long, so it cannot converge the rays into the retina anymore, or the eyeball has become too small. So either the focal length of the lens has become too long, or the eyeball has become smaller in size, so the ray which used to focus on the retina is no longer able to be focused on the retina, and you are not able to see closer objects. Now this kind of eye defect, what type of lens we use to reduce this effect? Okay, name the type of lens used to correct this defect and state its role in this case. Now here the focal length of the lens has become more, right? That's why the ray is converging behind the retina. Now what we have to do, we have to make these rays focus closer to the eye, so that they you can see the objects which is closer to her. That means we have to use a convex lens. Okay, convex lens helps to focus the rays closer to the retina. So basically we have to use a convex lens. So answer is convex lens. Okay, because it helps to focus the ray on the retina. It helps to focus rays into the retina. If you answer this, if you write this much, you will get full marks, don't worry. Now one more question on this human eye. Now this is a small answer type question, short answer type question. Define the term power of accommodation of human eye. Write the name of the part of the eye which plays a major role in the process of accommodation, and explain what happens when human eye focuses nearby objects and distant objects. So basically what they have asked you, first of all, what is accommodation of eye? So accommodation of eye is the ability of the eye lens to adjust its focal length, is called accommodation of the eye, or normal accommodation. So basically what does it mean? So using our single eye lens, we can see objects which is very far. Okay, for example, we can see stars, we can see moons, we can see sky. But using the same lens, same eye lens, we can read our books, we can watch our TV, we can watch the video that you are currently watching. So using the same eye lens, we can observe different things. So what is the meaning of accommodation? Accommodation is the process by which our eye can adjust the focal length. That is called accommodation of the eye. Now, however, the focal length of the eye lens cannot be decreased below a certain minimum limit. So focal length cannot be decreased to a certain minimum limit. That is called the near point. Okay, and far point is basically the infinity. For a normal human eye, you can see objects up to infinity. Okay, but you can see up to a certain close limit. Okay, that is basically you can increase the focal length up to certain limit. Okay, that is your near point. Now the ciliary muscles plays the major role in the process of accommodation by adjusting the curvature of eye lens. So basically if you have seen the structure of the eye, okay, there is a lens and there are some muscles. Okay, these muscles are called ciliary muscles. They can relax, they can extend, they can contract, and based on that you can see different objects. Let's see how this works. For so explain what happens. Human eye focuses nearby objects and distant objects. So when we are looking objects closer to the eye, the ciliary muscles contract. Okay, so when we are observing something very close to us, okay, like we are reading a book, okay, the ciliary muscles contract. Okay, this increases the curvature of the eye lens. The eye lens then becomes thicker. Consequently, the focal length of the eye lens decreases. Okay, this enables us to see the nearby objects clearly. Okay, so basically what is happening, your eye lens as I explained, this is eye lens, so ciliary muscles, they contract, so your lens now become a longer one. Okay, so basically radius of curvature increases. As the radius of curvature increases, its focal length decreases, and you can see closer objects perfectly. When the muscles relaxed, when the muscles are relaxed, so this is the relaxed position. Okay, this is the stretched position. Okay, when the muscles are relaxed, okay, the lens becomes thin, thus its focal length increases. This enables us to see the distant object clearly. So using the muscles, and it is an automatic process. Okay, as long as our eyes are healthy, and if you are observing something which is distant and close, you can immediately, your ciliary muscles can adjust, can accommodate a different range of objects, and thus we can see different objects based on the position of the ciliary muscle. So this is very important question. Okay. Now another question, another short answer type question. Name the type of lens presented by opticians for the correction of the hypermetropia. Okay, so hypermetropia, we already learned that when we cannot read objects which is closer to our eye, that is called hypermetropia. State the role of such lenses in correcting the vision of the person suffering from this defect. Okay, opticians prescribe convex lenses, so as I said, okay, also called converging lenses, for the correction of the hypermetropia, commonly known as farsightedness. Okay, so farsightedness and hypermetropia both are same. Okay, but sometimes this term farsightedness and nearsightedness are confusing. Okay, farsightedness means you cannot see objects which are close. Nearsightedness means when you cannot see objects which are far. So sometimes students, and I don't know why this was named like this, that is mainly because how the lenses rays are getting focused. Okay, behind the retina means farsightedness, before the retina means nearsightedness. That's how I think the name came. So that's why the name is sometimes confusing. Farsightedness means you cannot see objects which are close, not which are far. Okay, so be careful. Convex lenses help correct the eyes focusing issue by making the near objects appearing sharp. Okay, that is what convex lenses do. So this is the basic answer for this question. Now let's look into the homework question from my previous class. So what was the homework questions? Absolute refractive index of a glass and water is 2/3 and 3/4 respectively. If the speed of the light in the glass is 2 times 10 to the power of 8 meter per second, the speed of light in water is. So what they have given? They have given the refractive index of glass. It is given by 2/3. Refractive index of water is 3/4. Okay, now we know that refractive index, absolute refractive index, is nothing but speed of light in free space divided by speed of light in that particular medium, right? Similarly, this will be C by V water. Right now, let us, this is given, I think. Speed of light in glass is given. You are supposed to find the VW. So what we have to do first, let us write this like Ng by Nw. Okay, Ng by Nw is 2/3 divided by 3/4. That is 2/3 multiplied by 4/3. Right? So this will reverse. So now it will become, so the data given here is incorrect. It is not 2/3. It should be the absolute refractive index of glass should be 3/2, and absolute refractive index of water should be 4/3. Okay, so there is some data issue. So I am sorry if you are not able to solve this correctly because of this. So let me correct that here as well. So it will be 3/2 and it will be 4/3. Right? Now let me solve it, correct it here. So it will be 3/2 divided by 4/3. So 3/2 times, it will reverse, it will be now 3/4. So it will be 9/8. 9 by 8 is the relative refractive index. Now what is Ng by Nw? Ng by Nw should be C by Vg divided by C by V omega, sorry, Vw. So C by Vg times Vw divided by C. C cancels. So Vw is now Vg times Ng by Nw. Right? Now Vg is given 2 times 10 to the power of 8 times this value you have calculated, 9 by 8. So it will be 9 by 4 times 10 to the power of 8 meter per second. Right? So correct answer is option A. Okay. So I'm sorry if you are not able to solve this question because of this data mismatch, but you are aware that refractive index of any medium, absolute refractive index of any medium should be greater than 1. Okay, only air and vacuum has refractive index of 1. Other than that, all other mediums have refractive index greater than 1. Okay, refractive index less than 1 means speed of light is more than c in that medium, which is not possible, right? So let's move on to the next question. How will the image formed by a convex lens be affected if the upper half of the lens is wrapped with a black paper? So we have a convex lens and upper half is wrapped in a black paper. Okay, now what will happen? So the image will still be formed because the rays will still be passing through it and it will form an image. Okay, does not matter, rays can still pass. Okay, rays will still pass through it, and only thing that will happen is the brightness of the image will decrease. Okay, sometimes you might think, okay, what will happen if I close our eye by 50%? Can you not see? You can still see. Okay, if you close your eye 50% using your hand or using a paper and you close the other eye, you will still be able to see anything. Only thing that will happen is the image that is being formed will be less bright. Okay, because 50% of the ray is not traveling, but the rays are traveling in a straight line and it can travel in all possible direction. So the ray will still travel and it will still form the image. So very interesting and important question. Okay, the brightness of the image will reduce. Other than that, everything else is incorrect in this case. Now Sudha finds out that the sharp image of a window pane of her science laboratory is formed at a distance of 15 centimeter from the lens. She now tries to focus the building of her outside the window instead of the window pane without disturbing the lens. In which direction she moved the screen to obtain a sharp image of the building? So basically what is happening is that, suppose we have a convex lens. There is a window pane which is there is a window pane at some distance, and through the window there was some house, okay, building, nearby building. So initially what is happening is that she tries to focus this window pane and she observed that the image is formed somewhere at 15 centimeters. So she observed the image is formed at 15 centimeter distance, right? Now she wants to focus without disturbing this lens. She wants to focus this house. Okay, she wants to focus this house. Now what will happen? So the same thing will happen, only thing that we know that object is now moved far away. Okay, so object moved far away means you have to bring the screen towards the lens. Okay, so first of all she needs to move the screen towards the lens. Why towards the lens? Because as we know, you can consider this is a very distant object. For a very distant object, okay, we know the rays are parallel. Okay, so they will exactly focus on the focus of the lens. So we can consider this home to be a very distant object, and the rays coming from this object is parallel and they are actually focusing on the focus. Now when the object is closer, Okay, in that case the ray will be forming somewhere here. Okay, so what we have to do, we have to bring the screen towards the lens. Remember that you have to bring the lens towards the screen towards the lens, and this window pane itself was very far away. Okay, so window pane is not very close object, it is at least 5-10 meters away from the lens. So for that also you can consider it to be a distant object, and the approximated value of the focal length is actually 15 centimeter. Okay, so you can consider 15 centimeter to be an approximate value of the focal length. Since they have asked you approximated value of the focal length, so you just need to find the focal length. You can use this method, and approximated focal length is 15 centimeter. Now let's move on to the next question. How are power and focal length of a lens is related? Okay, you are provided with two lenses of focal length 20 centimeter and 40 centimeter respectively. Which lens you will use to obtain more convergent light? So power is related by 1 by f. Okay, I think I have solved similar question in our previous class also, where f is in meters. Okay, so power of the lens, both of the lenses have 20 centimeter, one is 20 centimeter, so 1 by 20 times 10, not 10 to the power. For centimeter, what you will do, if the focal length is given in centimeter, you just use 100 by focal length. Okay, so this is a direct way to calculate the focal length. So it will be 5 diopter plus 5 diopter. Okay, and that means it's a convex lens, that's why plus 5 diopter. And for the second lens P1, P2 is 100 by 40, so it will be 2.5 diopter. Now since this has a higher power, it will produce more convergent light, so you will use the focal length with 20 centimeter. Okay, less the focal length, more power means more convergent, right? So you have to remember this. Now the image of a candle flame formed by a lens is obtained on a screen placed on the other side of the lens. So they have mentioned that there is a lens, okay, and there is a candle light, and you obtain the image on the other side. So other side means it has to be a convex lens. Okay, only convex lens can form the image on the other side. For concave lens, it will be on the same side as the object, right? So only concave lens is possible, convex lens is possible. Now if the image is 3 times the size of the flame, okay, if the image is 3 times size of the flame, okay, and the distance between the lens and the image is 80 centimeter, at what distance should the candle be placed from the lens? So what is said that the magnification for a lens, we know that it is V by U, okay, and it is given at 3 times. Okay, so magnification is 3 times, and V is given 80 centimeter. V is given 80 centimeter. They have asked you to calculate U. So it will be 3. So what will be U? U will be 80 by 3. So it will be 20, almost 27. Nearly equals to 27. If it was 81, it would be 87. So you need to place the object nearly 27 centimeter away. Okay. Now what is the nature of the image of the at a distance 80 centimeter on the lens? So nature is, it must be real image as it is forming on the other side. Second is, it should be inverted. As we know, real images are always inverted. And thirdly, it should be magnified, as it is mentioned 3 times. So magnified. So when they ask you the nature, you have to mention everything about the image, okay, whether it is real, whether it is virtual, whether it is magnified, whether it is diminished, okay, you have to mention everything. Now another question, a student focused the image of a candle flame on a white screen. Similar question, okay, using a convex lens. Now here the nature of the lens is mentioned. He noted down the position of the candle screen and the lens under the position of the needle. So basically what you are doing, you are doing the experiment in a system called optical bench, where you place the lens at some distance, you place one object, and then you place a screen. Okay, So these are the basic structure of an optical bench. This is called an optical bench. Now what are the main distances? Candle is placed at 12 centimeter. Okay, so somewhere on the left hand side there is a 0. Candle is kept at 12 centimeter. Okay, lens is kept at 50 centimeter. And the screen is placed at 88 centimeter. Okay, now let us find the distances. What is U? What is V? Okay, so U is 50 minus 12. That is 38 centimeter. What is V? V is 88 minus 50. That is also 38 centimeter. So the image distance and object distance are same. Now when does it happen? Okay, when does it happen? It happens only when the object is placed at 2f. You can use the lens equation here. No need, but since we have received the object in distance and image distances are same, so from there we can write that this means that object is placed at 2f, that is 2f is 38. Okay, because both distances are same, object distance and image distances are same, that means object must be placed at a distance 2f from the lens. That means we can write 2f is equal to 38 or f is equal to 19 centimeter. We don't need to use lens equation here. Okay, after this if you use the lens equation also, you will get the same answer. Okay, so don't worry, but you can use direct approach. It is much shorter and much direct approach, so you don't need to worry about it. Next question: where will the image be formed if he shifts the candle towards the lens at a position of 31 centimeter? Now when the candle is shifted to say a distance of 31 centimeter, now what is the object distance here? Object distance will be 50. Lens is at the same position, right? Only candle is shifted, so it is 19 centimeter. So the object is now placed at focal length, okay, at the focus of the lens. So at the focus of the lens, image must be formed at infinity. Right? So when the object is placed at focus of the lens, the image must be formed at infinity. This is a very important question. Even though the two questions look similar, this question is completely different than the previous question. What will be the nature of the image formed if he further shifts the candle towards the lens? Now it is if now U is less than f. So in that case, we know that convex lens will form virtual, erect and magnified image. Okay, so the nature of the image will be virtual, erect and magnified. Draw a ray diagram to show the formation of the image in case 3. So this part we have done in our previous class. If you have missed it, don't worry, the video is there in our channel. You can go and watch light refraction. If you watch light refraction, there we have discussed everything in detail about how to draw the ray diagram. So here I am just briefly drawing it so that when you are getting the answer you can draw it. So the object is like this. Okay, so suppose this is the focal length. Okay, not this ray. My mistake. The distance should be less than the focal length. Okay, so this should be the ray diagram, something like this. Okay, this is a rough ray diagram. that I can draw quickly, but I have explained detailed process of how you can draw the ray diagram in my previous lecture, so don't miss out on that if you want to learn how to draw ray diagram. Now let's move on. Every lecture including the class notes is available in our website. You can click on the link given in our description and download the lecture from that page. Okay, so everything is available in our website. You just need to click on the link on the description and download the file. Now, dispersion of white light. Let's look into some more topics from today's lecture. A prism ABC with BC as base is placed at different orientations. A narrow beam of white light is incident on the prism as shown in the figure below. In which of the following cases after this dispersion, the third color from the top corresponds to the color of the sky? So very important. So there are few images. Okay, now they have given you different images and they asked you in which case the third color from the top. So if you are observing from the top, the third color from the top should be the color of the sky. Now what is the color of the sky? First of all, tell me. So if you observe from the top, and only one answer is correct. Okay, so what is the color of the sky? Color of the sky is blue, right? So third color is blue. That means we know that how the image is formed. So when if you pass a light from this side, you will see that the light will bend and they will bend, okay, and they will give you which color bends the most. Violet color bends the most and red color bends the least. So we know that. Let me use proper color so that in future you can use this as your reference. Okay, and we know that all the other colors will be in between, and the form of the color is VIB GYOR, VIBGYOR, but VIBGYOR from the bottom. Okay, so VIBGYOR from the bottom. So if you are observing from the top and you want to observe blue color, that is the third color of the sky, then you have to orient your prism like this. If you orient your prism like this, the red color will be scattered the least, so red color will deviate the least, and violet color will deviate the most. So after the diffraction, after they come out, okay, the blue color should be the third color. Okay, blue color should be the third color. Okay, in between there will be indigo color as well. Okay, so blue color should be the third color if you use the orientation like this, and you will see that you will get VIBGYOR. I don't have the space to draw all colors, but you should remember that when you are observing VIBGYOR is from down to up normally. So if you reverse the prism, the VIBGYOR will be from top to below. Okay, so you want to obtain the blue color, that is the color of the sky. So to get the color of the sky, you have to reverse the prism. Obviously in this case also red will be scattered the least, so it will be top. In this case also red will be top, so you will not get the desired VIBGYOR. Only way to get the answer is option 2. So correct answer is option 2, that is option B is the correct answer. Be careful to answer such questions. Now next question. Which of the following phenomena of light are involved in the formation of rainbow? Very interesting question. So how the rainbow is formed? Let us look into a diagram that will help you. So sunlight is coming, it is falling on a raindrop or some water droplets that is there in the air. Okay, once it is entering this raindrop, this is a refraction. This step is refraction. Okay, this is refraction. Okay, now once this light is refracted, okay, it is basically dispersing into 7 colors. Now at this surface of this raindrop, okay, it is happening, something is called total internal reflection. So reflection is happening on this surface, this is called total internal reflection, and that raindrop is again coming back, and you are seeing all the colors in a rainbow. So basically what all happening here, it is happening refraction, dispersion, dispersion and total internal reflection. So these three things are happening here. So the correct answer is option number B. Don't get confused, it is not a normal reflection, it is total internal reflection. Okay, so refraction, then dispersion. First stage is refraction, second stage is dispersion, third stage is total internal reflection. Again they are coming back, and then you are obtaining another refraction is happening. Okay, so be careful to answer this question also. Now one more short answer type question. What is the dispersion of white light? States it cause. Draw a diagram to show dispersion of a beam of white light in a glass prism. So this is very important question. So what is dispersion of light? Splitting of white light into 7 component color is called dispersion. Okay, different colors of light bend through different angles with respect to the incident ray as they pass through the prism, causes the dispersion of light. Now dispersion, I have already drawn one diagram. Let me draw one more. Okay, and remember that while drawing in the exam, you don't need to use color pencils to show all the colors. So you will use your regular pencil, okay, and while drawing it, but you need to be careful that the color started breaking up inside the prism itself. Okay, so don't many students draw it like this. 7 colors, they mention 7 colors and they mention Vibgir, but that is not correct. Okay, this is not correct. I have seen people drawing it like this. The dispersion starts happening inside the prism itself. Okay, so the red light, then the blue light. You don't even need to draw all the red 7 colors if you don't want. Okay, only thing you have to do is to draw it properly. Okay, and mark them V I B G Y O R. Okay, so you can draw all the 7 colors, but this is basically the ray diagram. Okay, you can draw 7 light. I don't think it is very difficult or very challenging. Okay, you can use. Okay, so this is the, but you have to put the arrows. If you are drawing 7 lights or 6 lights, or at least the boundaries should be drawn. If you want to invest more time, you can draw all the 7 lights. Okay, but you must be careful that V is at the bottom, R is at the top, and the dispersion starts happening at this surface only. Okay, these are the 2 important things about the ray diagram. Now scattering of light, this is another phenomena. Okay, scattering of light is when light ray traveling and they hit a air particle present in air, it changes direction. Okay, but without any refraction or without any reflection, only when it hits a ray of light, it changes its direction. So for example, a ball hits a bat and changes its direction, okay, without even hitting the bat. Even if the batsman is not hitting the bat, okay, a ball coming and it is taking the edge of the batsman, changing the direction. So you can imagine that the dust particle is the batsman, he is not playing the shot, he is only edging the ball. Ray is like a ball. Okay, so he is basically edging the ball and it is changing the direction. So this is called scattering. Okay, now at noon the sun appears white as light is least scattered. All the colors of white lights are scattered away. Blue color is scattered the most, red color is scattered the most. Okay, even though blue color scattered the most is one of the, none of the statement is correct except light is least scattered. Okay, so white means all the colors are present. Okay, like dispersion, due to scattering also we sometimes see colors. Scattering is also responsible for colors. For example, we observe the sky is blue, okay, the sea is blue, This is because blue light is scattered the most, one of the highest scattered light, okay, along with violet, but violet has very less quantity present in white light. Blue has more presence in white light, so that's why we observe blue light. Okay, why the sky does not appear red? Because red color scattered the less, so it almost travels straight. Okay, but this is our sky. Suppose this is our sky, the ray is coming. Okay, the ray is coming, sunlight is coming, red scattered the less and it goes straight, but blue scattered the one of the highest scattered light and it reaches our atmosphere and we observe that blue color. Okay, and that blue color is reflected by the sea. That's why we see the sea as blue. Okay, the blue color of sea, ocean color or sea color does not have nothing to do with the blue of the water. Water is not blue. Okay, water is transparent. Only thing, it reflects the sky, that's why it appears blue. Okay, so if you see next time a blue water, remember that this is because the sky is being reflected by this light. Okay, now let's move on. Next question. The clear sky appears blue because, so I have explained this question just now. Blue light gets absorbed by the atmosphere. Ultraviolet radiations are absorbed in the atmosphere. Violet and blue lights get scattered more than lights of all other colors by the atmosphere. Light of all other colors is scattered more than the violet and blue color lights by the atmosphere. So obviously, as per my explanation, violet and blue are the light that is scattered the most by the atmosphere. That's why we see, because after scattering it reaches our eyes, so that's why we see the sky as blue. Now, a danger signal installed at the top of the tall buildings are red in color. These can be easily seen from a distance because among all other colors, the red light, so this is also from my previous explanation, the red light scattered the least. Okay, that's why when the traffic signal is red, why the traffic signal is red? Traffic signal is red because we can see the red color from a very distant distance. Okay, so if you are driving a car or a bike or a cycle or a scooty, you can see that the signal is red. That means I have to slow down, I have to stop before the signal, right? So red light can be observed from a distance. Okay, so that's why the red light, when a driver is seeing a red, he can slow us down. Okay, even green and yellow are, even though they are not very they are scattered less, but they are not as less as red. Okay, so we have to stop people. If they are moving, if the signal is green, people are moving, that is fine, but if the signal is red, you have to stop, and that red color has to be seen by the driver from a distance. Okay, that's why red is used as a signal light. Okay, it's scattered the least by smoke or fog, so that's why it is used as danger signal. Now, another question. Why do stars twinkle but not the planets? Another very important question. The twinkling of stars is due to the atmospheric refraction of starlight. Okay, the starlight on entering the Earth's atmosphere undergoes refraction continuously before it reaches to Earth. Okay, so what is happening? Our atmosphere, you can consider our atmosphere. Suppose this is our Earth, and the atmosphere is basically consists of different layers of air. Okay, not only the stratosphere, troposphere, inside the troposphere also there are different layers. Okay, so based on the temperature of Earth, how close the layer is on the Earth, so Earth is basically hotter than outer side, so the air molecules present closer to surface is little bit hotter, so it is less dense, and when you move up the temperature decreases, so the air density is slightly more, and far away the density decreases far more because of the gravity in that case. Okay, so the light ray that is coming from a very distant object, only one or two rays are coming from that star. Okay, and those rays are going through multiple levels of refraction. Okay, and because of that, okay, the position of the star is slightly different from its actual position. So first of all, we don't see the star at its actual position, but this apparent position of the star is also not stationary. So what is happening? Because of the ray of star is here, suppose the ray is coming here and we are seeing the star is here. Okay, and this position is also not stationary, it's slightly vibrating because of the fluctuating density of the air. Okay, fluctuating density of the air, fluctuating refractive index of the air. So this position keeps on changing slightly. Okay, the planets are much more closer to the earth and thus seen as extended sources. So stars are very distant. Okay, the only closest star is sun. Other than that, all other stars are very, very far away. So the light coming from those stars are very less. Okay, so we don't get too much light from that star. So that's why even one ray is coming, that ray is fluctuating. That's why we are seeing the stars twinkle. But from the planets, multiple rays are coming. Even if one ray is going through fluctuations, other ray coming from other direction, they are having fluctuation in another direction. So average position of the planet does not change. We can consider this as an extended object, and that's why they do not twinkle. Okay, now which of the following phenomena, now let's look into the homework question, today's homework question. Okay, I have completed all the topics from this chapter. This chapter, as you have understood, is not super important for long answer type questions. Sometimes some case based question based on your eyes, okay, based on your some diagnosed by the doctor. So they will give you a case where you visited a doctor and their doctor said you have some eye disease, that's why you are not able to see distant object or closest object. That is one case based question, and mostly multiple choices and 2 and 3 marks question comes from this chapter. Okay, 2 and 3 marks question will definitely come from this chapter. Okay, long answer type questions are rare, but maybe for your midterm question they might ask one typical theoretical questions. That also we have discussed in our discussion. Now let's look into the homework question. You can read the homework and answer this. Okay, let me read the questions for you. You can pause the video, take a screenshot, answer this, and mention the answer in the comment below. If you are watching this up to this point, which of the following phenomena contributes significantly to the reddish appearance of the sun and at sunrise or sunset? Okay, so what is the reddish appearance of the sun? Because during sunset and sunrise. Okay, so you have to answer the options. Next question, the bluish color of water in deep sea is due to. I have explained this question. Read this and try to answer this question. Okay, what is the correct option? Next question, short answer type question 1. Draw ray diagrams each showing myopic eye and hypermetropic eye. So both are important questions. Now next question is from one of your previous years. A person needs a lens of power minus 4.5D for correction of her vision. Okay, what kind of defect in his vision if she is suffering from? Okay, so this is kind of a case based question. What is the focal length of the corrective length? What is the nature of the corrective lens? So this is a kind of complex question, because this question requires knowledge of lenses as well. Okay, but not difficult, easily solvable. So you can answer this. Now next question, one long answer type question. A student sitting at the back of a classroom cannot read clearly the letters written on the blackboard. What advice a doctor will give it to her? So this is also a case based question. Draw a ray diagram for the correction of this defect. So you have to identify this defect and then you have to draw the ray diagram for that. And if you are not able to answer these questions, I will be back with the answers in our next class that I think you will be coming on Sunday. So on Sunday I will be back with all the answers. Till that time you can try and answer these questions. Also, if you are currently studying in class 10th and you are wondering what you should study, what should be your focus for in your class 11th, should you go for engineering studies, focus on engineering JEE mains, KCET or any other engineering related exams, or you should focus on NEET, NEET or medical studies, what you are suitable for, what is your future looks like. If you are confused about that, don't stay confused. Diksha is presenting Diksha Scholastic Aptitude Test or DSAT. Here you will have to attend a class. Then after the class there will be a test, aptitude test. Once your test is done, based on your test result, there will be a counselor available to you. for absolutely free, and that counselor will guide you, that counselor will give you advice on your career. Also, if your score is good in DSAT, you can get up to 90% scholarship if you take admission in any of the Diksha colleges for class 11th and class 12th. So what are you waiting for? Don't forget to register today for DSAT, and our representative will contact you soon. And if you are wondering from where I can download all the lecture notes, all the class notes, for that you have to visit our website and click on the download button. Every lecture along with the video will be available in our website. You only need to click on the link and get the lecture from there. Thank you for watching. I will be back with a new video of electricity in our next lecture, and we will be completing our midterm term booster score. Also, there will be a very surprise thing is happening on for your midterm. You will get that update once all the lectures are over. Thank you for watching.